I start with thanking Michael, the number 14 speaker, who is willing to switch the position with me. I'm supposed to be the number 16. My last name is probably a lot easier to remember than my first name, the Huo. And appreciate the opportunity here. I think I'll start with saying that in my title, I listed something called spatial-temporal modeling. And I probably will step back saying that we're actually doing a lot more than that. So this is one of the things that we are doing. And the bigger picture of what we are doing is that I'm trained as a statistician, and I got my PhD degree in statistics 20 years ago. And nowadays, we probably try to move to convert ourselves to be the data scientist. And on that aspect, we're actually regularly teaching, and also our students are doing a lot of things which are related to statistics and machine learning, and now probably is called data science, including stuff like it used to be when we were graduate students, we used to do a lot of things which is called multi-resolution analysis, like the wavelets and all kinds of the multi-resolution or all kinds of the fancy transform at that time. And then after 90s, after the peak of the wavelets, and then it becomes a support vector machine, becomes very popular. So we also, we regularly teach the support vector machine, and also we write papers talking about the properties of the support vector machine. And then afterwards, we also, then the random forest is becomes another popular. So every industry, when they do segmentation analysis, start using the random forest. I guess nowadays, the hot topics becomes the deep learning. So what I want to say is that we train students to learn all those techniques, and we have the tools. So our students are good at Python programming. So in the classes, they actually get homework problems which are related to how to, for example, apply the deep learning to some natural language processing projects. And because of, thanks to the open source and the database which is available, and students, they know how to use a TensorFlow and PyTorch, those kind of technique to implement those. So they are very they are trained on those kind of techniques. So we have a lot of so if you're looking, if you have a particular application problem, and if you think that some of the particular methods or algorithm might be useful in this algorithm, and you would like to talk to somebody who probably can do some experiments for you, so maybe some of our students can do that. And beyond that, in our research, what we do is we call ourselves the foundation side of the data science. And the foundation means that we are not, if I talk about the data science or machine learning, one thing we can think about is that if there's an interesting application problem and data is generated, then the next question is which algorithm I should apply or which model I should build so that I can get some meaningful results. And as a matter of fact, there's hundreds of, it could be deep learning, it could be support vector machine, it could be random forest, or could be many other, there's probably hundreds of options out there. Then which one is good? Which one I should use, and what are the properties I should know of those algorithms which can fit into my scenario. And that part of the work is probably what we do. So we look at those algorithms and try to provide a deeper understanding on the performance of those algorithms, the domain of applications, the pros and cons of different algorithms. So if you have a project, you're not only looking at try one particular algorithm, get some good results, you also, the matter of fact, in a lot of scientific publication, if you just use one algorithm on particular problem, it's probably not enough to be considered publishable, especially top journals. Most likely you have to say some properties. So for example, under this scenario, this is the best, this algorithm has the best performance in some sense, or maybe the best possible minimax rate you can derive in these situations. If that's what you try to achieve, so maybe talking to us and we can try to develop some joint projects out of it. And I probably also say that we have we have a lot of students, and we have many colleagues who are doing similar things. We have a statistical center. We have like almost 10 faculty members who are doing similar things like what I do. And we also have an institute which is aiming at the foundation of the data science research. We call it the tripods. And if you want to know more information, go to the following URL, which is triad, TRIAD, and .gatech.edu, and you probably find more information about this. And I think I'll stop here. Thank you.